Hi everyone, welcome back to my number sense series. Today we're going to be doing more multiplication, but don't worry, this is kind of advanced multiplication. This is what I call searching for tricks. So if you remember back to all our other multiplication videos, I usually had one question where the trick was kind of hidden. You had to maybe manipulate the numbers, look at the question in a different way in order to get to the trick, but it was still a little bit easier because I told you what the trick was. Here, all of these questions are like that. The trick is going to be hidden and you have to determine by yourself what the trick is. So it makes it quite a bit harder, which is why I said it's advanced, but don't worry, this is still very, very possible with a bit of practice and some pattern recognition. So let's get into it. Our first question is 35 times 18 times 25. Now, there are actually two ways that I immediately thought of to do this question, but one of them I thought of first and one of them I thought of second. So I'll present both of them so you can see, kind of compare your thinking, see which one you would have thought of, which one you wouldn't have, but just know that these are both two perfectly fine ways to do the question. So the first approach is to simply multiply 35 and 18. So 35 times 18. Now, this is not a super nice, product to evaluate, but we can make it a bit nicer because we notice 35, right? That's half of 70. It would be nice if we were multiplying by 70, so we can get a 0 at the end. So what we can do to make a 35 into 70 is to use what I call the double and half trick. In other words, we're going to take a 2 from the 18 and give it, this is 9, and give it to the 35. So this becomes 70 times 9. In other words, what I've effectively done is doubled this number and halved this one, and you should see that the product will remain the same. So 70 times 9, much easier, 630. So then we're left to do 630 times 25. And you can see again why this is advanced. It's usually going to be multi-step, kind of difficult to do in your head. 630 times 25, what's that? Well, we can use the 25 trick, right? 63 times 25, what is that? Well, 63, when you divide it by 4, you get 15 with a remainder of 3. So it's going to be 15, and these last two digits are going to be the remainder, which is 3 times 25, 1575. But wait, there's a 0 at the end. 15750. That is one way we can do this question. The other way is to multiply 18 and 25 first, and this is going to result in a different step over here. 18 times 25, we can once again use either our double and half trick or our 25 trick on the 18. Either way, what you're going to get is 450. Now we have to do 450 times 35, or in other words, 45 times 35, then add a 0 at the end, right? Same thing. How can we do 45 times 35? Well, this is a difference of squares. We see that 45 and 35, what's in between them? The average is a 40, right? 40 is a nice number to square, and also 5 is a nice number to square. So what we're going to do is we're going to think of this as 40 plus 5 times 40 minus 5, right? So this would be 40 squared minus 5 squared, which is 1600 minus 25, which is 1575, with a 0 at the end. Same answer. So you can see that these questions are difficult, right? I'm not going to lie, these are probably the hardest multiplication questions we have ever done on this channel, and there's 5 of them. But it's really important that you kind of look at these questions and you develop the skill to kind of understand what trick you have to use, the way in which you manipulate these numbers to make these tricks happen. It's super, super important. So if it seems hard, it's supposed to be, so don't give up, right? Keep trying, guys. 33 times 24 times 75. Once again, there are going to be kind of two ways to do this question. I will present both of them. The first way is to look at that 33 and immediately notice the 33, okay? Whenever you see a 33, you should be thinking about two things, either 11 or 99. We can think about a 99 when there is another factor of 3 in the question. And here it appears that there is, right? There's 24, which has a factor of 3, and there's also 75, which has a factor of 3. So now we just have to decide which one we're going to take from. So this is kind of where the two methods diverge. They branch, but they all lead to the same answer. Our first case, what if we take a 3 from the 24? Then we have 33 times 24 equals 99 times 8. Then it's going to be 99 times 8 times 75. So then we do 8 times 75 first. 8 times 75, we can either write 75 as 100 minus 25, think of it that way, or we can think of 8 times 25 as 24. 8 times 75 is 24 times 25 and use our 25 trick. Either way, this is going to be 600. 99 times 600. Then we use our 99's trick and we get 59400. Now we can also do this another way. If we do first 24 times 75. 24 times 75, what I would do is think about this as 24 times 3 times 25. It's going to be 72 times 25. 72 times 25 is going to be 1800. Now 1800 times 33, we have to decide how we're going to do 1800 times 33, right? 1800 times 33, we can either write this as 5400 times 11, or we can write it as 600 times 99. So in some ways, this actually groups back with this and we get the same answer, or we do 5400 times 11 and we can use our 11's trick. Either way, so if we do this, we'll get 49500. We get to that. So you can see there's a lot of like branching pathways, right? At the start of this question, I mentioned that there are two pathways diverge. I didn't mean this, I meant there's two pathways inside of this method, and there's also like kind of two pathways inside of this method. But really, when you're in contest, don't like think too hard about what you're doing, because if you try to get like really far along this pathway and you realize, okay, maybe this is a little bit easier, and try to backtrack and go back over here or go back over here even, that's going to take way too long. You might as well just finish the problem with a certain way if you've already started, unless it is like super, super complicated and there's seriously nothing nice about it. Then you can consider abandoning. If you get something like really ugly, like 43 times 92, like who's doing that? But usually it's going to be nice. Now our next question, 7 times 9 times 13 times 11. Now, the method I would use in this question is a little bit easier to recognize. Do you guys see it? It is 1001. 7, 11, and 13, famously, hopefully you know this, they make 1001. So this is actually 1001 times 9, which is so nice, right? This is just 9009. But if you don't see that, don't worry, not all hope is lost, because there is another way. This way is harder, but it's also a valid way to do it. It is grouping. We can group this and we can group this. 7 times 13 is 91. 9 times 11 is 99. And this is 91 and 99. We can use our trick for multiplying numbers in the 90s, right? So I'll run through that again. So remember, when we multiply two numbers in the 90s, we have to keep kind of two other numbers in our mind. And those two numbers are going to be, the critical ones. 91, how far does it differ from 100? 9. So 9. How far does this differ from 100? 1. 9 and 1, those are our two numbers. So we're going to have 100 minus 9 minus 1. What is that? That's 90. And then 9 times 1, that's 9, or 09. And so we also get 9009 as our answer. So once again, two ways to do the question. One of them is easier than the other, but as always, all roads lead to Rome, right? Now this question, there is only one way here that I would really recommend doing, but I'm sure there are other ways if you are dedicated enough. The key observation to make here is that we can once again group, and this grouping is going to create something even nicer than it did over here. And this is kind of something that you just have to kind of get a feel of to recognize. 3 and 36, they make 108. 9 and 12, they make 108. So when you multiply this and this, then this and this, it's 108 squared. And we have a trick for multiplying two numbers that are in the 100s, right? 108, so it's 1, then 8 plus 8 is 16. Then 8 squared, 8 times 8 is 64. So our answer is 11664. So this is an example of a question where you really have to recognize the trick. There's really no two ways about it. But I think if you gain enough practice with this kind of question, if you're in contest and fiddling around with the numbers, you will eventually get it. It just comes down to practice for how long it takes you to get it. Last question, 6 times 4 times 37 times 17. This is once again one of those like kind of questions that should make an alarm go off inside your head, right? Just like kind of this question with 7, 11, and 13, this question with 33, 37 is one of those numbers that should set alarms off inside your head. Because what is 37? 37 has two really important things about it. The first thing is that 37 times 3 equals 111. The second thing is that 37 times 27 equals 999. So when you see 37 in a multiplication problem, really try to make those two things work because there's like a 95% chances about that. Here, we don't have enough 3's to make it into a 999, but we have a 3 from this 6. This 6 can make it into a 111, and that's what we're going to use. So it's 6 times 4 times 37 times 17. If we take that 3 from the 6 and give it to the 37, what we have is 2 times 4 times 111 times 17. Now, in order to use our 111 trick, we have to multiply these first. 2 times 4 times 17, that's 8 times 17, which is 136. So it's 136 times 111. Now, we have to apply our 111 trick. So I'm going to start from the right? I'm going to write 6. Then my next number is 6 plus 3, which is 9. Then my third number from the right is 6 plus 3 plus 1, which is 10. But I can't write a 10. I have to write 0 and carry a 1. Then I'll have 3 plus 1, which is 4. But 4 plus 1 from that carryover is 5. And I'll have just 1. So just to recap, the digits go like this, 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 this. 15096. So that is advanced multiplication, right? Searching for tricks. And I will admit, this is a hard video. I should have said it at the start, but this is a hard video because it requires you to not only know the tricks, but sometimes apply them multiple times in a row, all while the trick isn't even obvious. You have to search for it. But if you can do these problems, you can be sure that you are absolutely going to be set for pretty much every other multiplication problem in number sense. In my opinion, this is about as hard as it gets. So practice with these, maybe try to make up some questions yourself. Think about how can number sense hide these tricks that I know, and then you'll be very well set for multiplication. So that's it for today. Thank you guys for watching, and I'll see you next time.